I'm pleased to introduce Sue Harris and Jeff Haas, who will be presenting IETF Working Group Interdomain Routing, also known as BGP. Sue and Jeff are co-chairs of the IDR Working Group at the IETF, where BGP is standardized. Sue is currently a consultant for Huawei and a professor at Regent University. She has been the IDR chair for over 25 years. Her first presentation at NANOG was DVM-RP ping updates to gated at NANOG 6 in San Diego in 1996. Jeff Haas is a distinguished engineer at Juniper Networks, where he works on the implementation and specification of BGP. Jeff is the chair of the IDR Working Group, and he's also chairing the BFD Working Group. So with that, let's welcome Jeff and Sue.
Welcome. If you're bored, how many people can hear me? Good?
Excellent.
I bounce. Jeff bounces. Sorry, we're lively. Okay. How many people work with BGP? Oh boy, it's a room. Okay. So, who are we? A little bit of background on us. I started in the 80s with an ISP and a factory network. NSF, NOG, GateD, gave away freeware to 200 companies who put it in their work, had a team that did the coding while I tried to make sure it worked right. I then moved to the same job in a commercial company and then into as a DE in FutureWave. Last decade or so, I've been doing consultant for Huawei and a PhD. If you ever want to hear about what a PhD student does and becomes a professor, well, that's fun. My PhD is in the business. It's Jeff's turn.
So I worked at a small tier 3 ISP in the late 90s, MSN if any of you are from Michigan. And after 3 years of working at that, I had a lead on a job, which eventually got me working for Sue for a few years. And Sue introduced me to IETF work by saying, hey, I have this BGP MIB thing that needs a tiny bit of work. How do you feel about that? And here we are many years later. These days I spend my time actually working on the BGP stack over at Juniper, do a lot of infrastructure work, and I have the fun sort of split job of talking to customers, working on standards, and working on code.
So, isn't BGP done already? What do you think, Jeff?
Well, how many of you have actually put some feature into your network that is a new BGP thing in, let's say, the last 2 years?
Oh, good.
So, small number of people. BGP is a relatively stable protocol from the internet service provider perspective. So this sometimes you view with the opinion of, would you please stop messing with the protocol so my network can stay up? That said, BGP is used for an awful lot of things these days, and as much as we want to leave it stable, we actually have people that are constantly wanting to add stuff to it that is appropriate for different crowds. If any of you have, actually, show of hands, how many of you use large BGP communities? And this is a feature that came in just a few years ago, so this is IETF continuing to do good work. That work, in particular, was driven by operators who participate in IETF. So this is a place where operational challenges end up having protocol impacts that let you get your job done day to day.
So BGP is used for VPNs and BGP services for multicast. You saw EVPN. You also saw in the previous slide SR routing. Well, we're going to try to tell you a little bit about them and tell you that the most important thing to us as co-chairs in the standardization is you. Because it's operators that cause us to keep working hard on it, because it's important that you have the tools you need and you don't have extra cruff. The problem is some of you want some things, some of you want others. So we're looking for feedback. And you can participate in the IETF. It's an open standardization. Where do we do the work?
Well, the work happens all over the place. So, the primary work happens on the mailing list. You can join up the mailing list, make comments, watch things go by, throw in comments, ideally, productive ones. We also meet 3 times a year around the planet. We have a rotation between North America, and the next IETF is coming up in July in Vancouver. Europe and Asia usually. We've had occasional things like Brisbane, the most recent one. Argentina is a prior one. So the work does actually have, just like NANOG, an in-person presence where a lot of the hallway conversations can drive interesting things, but you don't have to participate. We have strong tools, specifically our MeetEcho suite, to allow you to participate and actually have some level of input remotely.
So we also hold interims, which are essentially teleconferences, and you can join those. Just log in.
So if I could, we are looking for people to help drive work in IETF. If you have interest in getting involved even this much and you don't know where to start, please seek Sue or I out after the fact, or we have many other people. And if we have a quick show of hands, who here actually does IETF work? So as you can see, there's plenty of people in the audiences that you can actually talk about how does this IETF thing work, or in many cases they'll say it doesn't work. So to work better, we need participation.
And in many of these calls, the chairs will ask, well, what does the operators feel? What are the people who are really using it? So let's go through the things we've been looking at for the last year. We've been working on intent or color routing. How many people have heard of color routing? Okay, we see the marketing mill's gone really good. And you have a trick question in the middle of that, so wait for that. Service routing and BGP-LS, we have a good portion of new presentations each year for some small feature. What about the BGP Yang?
So BGP Yang, we actually are done-ish with the first round of the model. It's actually going through implementation. Unlike some of the other organizations, we tend to be a little bit more centrally driven for things, and we're waiting for implementations to pop out to see if we're actually done and it's correct.
And that's just the basic one where we think the basic will help you manage your networks, but there are always additions for monitoring. As I noticed this people presenting, they had things they wanted. What about the stuck BGP sessions, Jeff?
So those of you who know Job Snyder, he was one of the people, again, driving a bunch of operators to help fix an interesting corner case in BGP. Any of you who've had zombie sessions stuck where for some reason the router is just simply not eating the routes and it lingers for way too long? Well, it's because the BGP protocol said we only care about what we receive, not necessarily what's being sent. So this is a case that we'll talk about in more detail where we had operators drive fixing a corner case in BGP that's been there since the beginning.
So we're going to go into details, but just so you know what's on the menu for tonight, we also have BGP over QUIC, which will be interesting. Jeff and Ying Zheng have been working on it, and I've been working on Flowspec V2, which is your Flowspec that you use. How many people use Flowspec? Okay.
Oh, brave souls.
So we're trying to give some new features that operators asked us for, which is, can we do user ordering of these instead of simply by components? We'll go through how we are working on it, and then we'll talk about old is new, things that you've heard in the past but have resurfaced this last year. So let me start. I've been the intent-based routing chair. Sometimes we give one chair an area. And intent-based routing is the user being able to signal the desire so that the service routes can go into the color route. So what does that mean? Someone asked me that the other day. I said, well, it happened in the pandemic. When my phone doesn't do the app that we pay a lot for, then we're upset for medical people or for other things. So the service route allows some tracking with it. Now, we have two portions of it, CAR, which is color-aware routing with a set of vendors, and CT, which is classical routing. Each have new service families, SAPIs, and each have two turns on the same problem. The chairs in their beginning said, we think these are functionally equivalent, but operationally different. So your test, when I present it, is to try to find that. If not, come up and talk to us. We spent 4 years refining because we had this two solution problem, and I'm going to give you 3 of the use cases that the authors presented. By the way, I copied this off the authors' presentations from 114, which is about 3 or 4 years ago. We also had a whole other group go off and say, oh, we're just going to do it by careful V6, SRv6 assignment of the SID. And that's the colored prefix routing. So let's dive into it. I think I've gone the wrong way. Okay. So here's the first example. You want multiple interdomain color paths. One path is low latency. You can see that there. The traffic comes in. Another, it's low latency and avoid this BGP path. And the third is low cost. Well, this allows them to set it up using BGP. Okay, that's the first case. This is car. The second is what happens if you have an edge with an access with only 2 things. Maybe you only have low latency and a particular other sequence. I think that was to run over a particular path, and there are things. But in the middle, in a transport network, you have FAR. So how do you handle that? Well, there's the mapping between 2 to 4. You can have color, you can have certain high bandwidth, you can have something, and then you can move back to it. So the specs are all about how do I move it? So that again, you can put a low latency in one end and get it out the other, or you could put a restricted path. Lastly, can you do transport anycast, where you send the transport off to an anycast server and it gets split? Okay, you got an anycast address and you do load balancing. Now, that was one. My challenge to you is how different is this? Here's an actual customer case from AT&T from BGP-CT out of the Juniper authors. You have a customer case from AT, they want to have RSP-TE and SRTE. Do people know that? Those are nationals, I hope. Yep. And the current network is RSP-TE, and they want to introduce service routing TE. They create different pathways, and on the top, they offer a particular silver service. Okay, that's one example. Here's another example. You put with Flowspec a particular traffic over RSVP and TE and SR tunnels to have it secure, and the other place is best effort. Again, 2 different colors, 2 different intents. You're redirecting the traffic to the service chain element to do the Flowspec and put the link on. Does it look similar to what we had earlier? Mm-hmm. If you think so, you're right. The last one is APAC. I've given you Moses's description, where they have different domestic and international, and they're independent along with their TE policies, and they wanted modularity for that.
And if I could too? Every one of these things that we're seeing across both solutions, if they look an awful lot the same, the answer is, that's because they largely are. I'm sure a bunch of you run RSVP across your network for different levels of reasons. Maybe you have a low latency path. Maybe you have one that is best effort. You're doing it for traffic differentiation. You're using it for traffic steering. You're already doing this sort of thing. So the question you probably are having out of all of this is, don't we have this problem already solved today? Well, the difference becomes, that's within a single network. The thing you're seeing between both of these solutions is that we're actually carrying this intent that you can do within a network through things like, classical forwarding, RSVP, LSPs, segment routing. How do you actually pass those intents from one network, from one AS to another? And this starts seeming like an interesting problem, because if you have more than one AS that you're dealing with, question to the audience, how many of you operate greater than one AS as part of your network? A smaller set of hands. So if this seems a little esoteric, it's because if you're a smaller network, the tools you have are probably good enough in isolation. But the second you start scaling out your solutions to inter-domain, this is where things get a little tricky. And this is where the use cases strongly overlap. But the solutions in terms of how they get managed are different.
So just to see how that might actually look in numbers, consider services with mapping communities. I noticed that other people had communities on there where they talked about it. Well, here's an example where you might have 4 communities. You might have one that does an auto resolution, and you have some that do custom. That's both good, but it goes over a color tunnel at the bottom. So these tools are there. The challenge for the standardizations people is when you get to 2 solutions that won't combine. As again, we saw, the chairs reviewed all of this in detail and said they were functionally the same, operationally different. So we'd like to hear feedback on this adventure. We had no end of fun. Anything else on car CT?
I think that's enough for car.
Okay, I got that. Okay. BGP-LS. How many people have BGP-LS in their network? I see maybe 1. Okay.
Actually,
how many people are planning to use or have SR routing?
There we go.
Okay, a few more. So we see a lot of proposals. We found inside the base BGP-LS some operational things that needed to be clarified so there were less bugs in implementations. We've done that. We also realized that BGP passes segment routing to candidate policy. Now, what does candidate policy mean? It's a fancy word for a dynamic tunnel that's being created. So you get an AFI-SAFI that proposes that you might have useful tunnels, and then a processing model called an SRPM calculates it, and you get it. Now, how are they doing? They got 2 types, SRv6, SRMPLS. I saw an SRMPLS earlier. What do we see as standardization? We see the far edge where we get minor refinements of these protocols, about 5 per ITF. So we need feedback from you to say, we're going to work on that one, or no, that one doesn't have enough support.
And if we could add into that, the number of hands we saw for LS at all, very small, which is a little surprising. So maybe a different question. How many of you are actively monitoring your IGPs and your networks through some sort of monitoring tool? Very small. Very timid person over in the other side of the room. So this is something that you might want to actually look at in terms of tooling, because it's easily available across multiple vendors.
Yep.
If you're trying to monitor your IGP, BGP-LS is a nice proxy for that, even if you don't have some of these subtle segment routing use cases. It's a great tool for that sort of thing. Far more interestingly, it's one that doesn't require you to tap your IGP in an unsafe fashion. So you can get some idea what's going on in your IGP for troubleshooting purposes without accidentally worrying about short-circuiting some bit of your LSDB and having terrible things happen.
So let us know. Here's a slide that shows you how the SR policy candidates really work. One BGP peer sends this SAFI. The peer 1 looks at it, says, I'm going to pick that tunnel. Okay, so it's really tunnels de jure. And the SRPM, SRPM, it real rolls off the tongue, folks, selects the active path from candidates. So BGP is shipping information. And just like BGP-LS, BGP is just the transport, although that is interesting to all of us. So, BGP Yang, your turn.
BGP Yang. So who was here for the presentation that was just before the break? That was covering monitoring things using GNMI and OpenConfig. I'm seeing a good number of hands here. So fundamentally, we're in an interesting place in terms of taking care of networks these days. It used to be that you could get an SNMP MIB to monitor everything. As I mentioned, my first bit of work that I got from Sue was let's work on this BGP MIB thing. And that's because you have to have something to pay attention to your network. And my job that I had before I worked for Sue, small, tiny ISP, I was still using SNMP tools to pull out state interface counters, whether peers are up and down, gang traps. Those sorts of things were extremely common, and then IETF, for interesting reasons, stopped working on them. The ecosystem was meant to be filled with Yang as the modeling language rather than MIBs. And the transport protocols for passing these things around started off originally as netconf, restconf, and what we've seen as other bits of the industry have worked on things. And we see that Google and some of their cohorts have been driving specific models for their purposes under OpenConfig as a modeling effort, and also providing tools like GNMI and other such stuff in their gRPC suites. We're IETF, so we have to serve more than just a smaller vendor set of things, even if there's a strong commonality. Those of you in the room probably have a lot of opinion that the stuff that Google's trying to cover with OpenConfig and everybody else working on the project, it is open-ish source. You can contribute and comment on things. And if you're an operator, they have a special place for you in their process, different than vendors. Your opinions matter more. But in IETF, we have a mandate to cover not just the cool things inside the protocol you need for day-to-day. We have to actually eventually cover the entire protocol suite. So we have a need for less config. We're not looking at generic config, a little bit like OpenConfig is. We're looking at modeling the operational status in a little bit better fashion, and we're meant to cover more of the feature suite. So the goal we had was, what do we actually cover inside of the initial set of modules that you guys in this room are going to want to try to use for monitoring your network? And the question became, what is core BGP these days? It's not just the base BGP RFC, because you have things like route reflectors, you have things like communities. These things are all extensions, but they're common ones. If this was old school MIBland, we would be doing these things one at a time and would never get there. We chose a common set in the Yang draft that we put together and covered a wide variety of ground. We also spent a lot of our time, since IETF process is a little more rigid about allowing for late changes, trying to make sure that the structure of the modules, right? So you can add the stuff later, not only for IETF purposes to add in the next IETF module, but if you're a vendor, having a good place to hook in your custom state for your customers off of the common models so that they can correlate the data. Those of you who are operating tools for monitoring your networks spend an immense amount of your effort of trying to figure out how do I tie one piece of state to another one. And it's our hope that we've gotten this effort right, and it'll make it a little bit easier.
We're really hoping, because what we found in the past work on network management is if you don't plan for the future, and perhaps you've seen that with other standardizations coming out of Google or OpenConfig, sometimes you get a block and then you have to go on. So we're trying to be there and do a good job of that. Because we intend to make Yang models for all the new BGP features. So that brings us to our last point. We really need to know your priorities. It sounds like we care. We're trying very hard to listen. Over the last 25 years, as I've been an IDR chair, that's made us successful. We just really need any feedback. Can you get us, you get to do the cool model you put in.
Yeah, and this one's from the Yang catalog tools that IETF maintains. This does cover modules outside of IETF, including OpenConfig. The problem that you run into, especially as you're working through, I'm an operator, I'm trying to actually figure out what to look for inside of my tooling, is finding the state in the first place. And the industry has some interesting challenges. IETF is running Yang catalog as one of its related services to actually say, how do these things relate to each other? And what you're seeing across many of the vendors is basically different types of explorers that pull state out. And here you can see as an example, the IETF BGP Yang module has a lot of dependencies. If you're to feed this to your favorite topic of interest, whether it's OC Yang modules, specific technology like an IGP, the dependencies are sort of daunting, but we actually have tooling to let us navigate things these days.
And one thing that Jeff has helped us work on is make sure we've put in the modules an easy forward path for when you change your IANA assignments. So you'll see that's baked into the model. So it's easy to actually see that and have someone else do the mundane work of, I say mundane, we really like IANA. So I think we're down to stuck BGP sessions, which I always think is a good topic.
So, as I mentioned, we had a bit of operator-driven work, to solve, this stuck session thing. BGP normally runs a hold timer if you don't shut the thing off. That basically says if I don't actually, see something from the other side in a timely basis, we're going to hang up the phone. The challenge that you have is that what happens if you're looking at the wrong side? If you're able to push things, things are working out okay. But if they stay stuck for a very long time, but you're maybe getting some of the messages from the other side, what do you do about that? And we see this for a lot of interesting reasons. Having been at the wrong side of bugs inside of BGP stacks and 3 different vendors at this point, sometimes you're just simply getting your socket calls wrong. Sometimes you have a bit of code on the other side that is telling you everything's okay, but really it's not. So
not if it doesn't let your traffic flow.
Yeah, so if you got some routes stuck behind you for some reason, if it's just keep alive, who cares? But what if it's a update message for you to get to YouTube? What if it's something that gets you to the root servers for your DNS? Stuck stuff is bad because it means that not only is your direct peer having problems, anybody downstream is now suffering this. So the proposal that was made is that we now add a send hold timer as well. Can you actually push the stuff out the wire? And based on TCP artifacts, any of you have had lots of fun doing TCP tuning, and we saw some nice TCP presentations earlier, during the analog. If you're having issues with TCP, the timers can go a little long. So you don't want to be as aggressive quite as some of the hold timer stuff, but you still want it to make forward progress. So the proposal basically says, if we actually can't send it for a while with some level of user adjustment, we're going to allow the session to be terminated. And of course, if you're terminating things, it's not great, ever. BGP takes a while to come up and converge, but you'd rather get the bad box out of the session. Design your networks for redundancy, you already do that. Get the bad boxes out.
And of course, this fixes some of the bugs. Oh, I didn't click to the picture. You should go through the picture and.
Yeah, so just very easily, the common thing that most people tend to see. Number one, if you're doing BGP for any length of time and have interesting headaches, you spend a lot of time in TCP dump. And the number one thing you end up looking for is zero windowing. If you're seeing a stuck zero window for a long time, that's an easy sign of this being a problem. The trick is it's TCP. There's a lot of fussy edge conditions where stuff could happen. Pick an easy example. Some vendors' nonstop routing environments interact with the stack by making sure that you can push out BGP messages atomically. So just because you have space in the TCP window doesn't mean that the implementation is willing to try pushing in some circumstances. So you could hang back and you're just basically, if you're not able to get the work done, you have to make choices.
So, consequences. What happens? You get it stuck running, and you think that it should be closed, but it's sitting there. And that's something we thought in the beginning that it would just fix itself. But since it's broken, it can linger, and BGP can get out of sync, and as Jeff said, the best way.
So here's the draft. It has been sent off to be an RFC. And this is a good example of how actual operators that care about IETF and participate actually drive solutions. So we have 4 known implementations and several more likely coming. This is another case also for open source. Just because you're not a big vendor, you can actually participate in IETF, you can drive work. Now, of course, as operators, you don't run strictly open source in your network, so the trick becomes making sure that the work is good quality and that eventually you get support from the vendors. And that's the usual headache. You have your product managers, they have to go fight of when is this feature going to show? Here's something to add to your list. If you care, just go talk to a product manager.
Because we count those equally. What's important to us is that you get something that someone's gone through an interoperability. Now, another proposal came out was the TCP user timeout. draft Chen IDR TCP user timeout. It was based on fixing a TCP feature to reset the TCP sessions. But whenever the data needed to be ACKed, and it had not been ACKed during a certain time period. That was fixing the problem at the TCP level. The difficulty is it wasn't deployed, it wasn't implemented. The benefit is it can deal with packet loss or TCP bugs leading to the dropped ACKs. This is still something that could be fixed, but again, deployment, interest, finding people who are going to work on it. If you have an open source that fixes something like this, let us know. Did I miss anything on that one?
We got this one.
I got that one. BGP QUIC.
So this
this
is a fun one. A few of you have been in the bar when I've had conversations about this, and those of you who live in basically podcast style land might be familiar with Jeff Doyle, Jeff Tansura's Between Two Geeks. We had a presentation. Myself, one of my co-authors, Ying Zhen, Alvaro, and Jeff Tansura. We are working through what does it mean to do BGP over the QUIC protocol, and the bar conversation here is immediately, WTF are you doing? Now, what is the motivation for doing this strange thing? Well, so one of the things to realize that's sort of a backing detail, BGP happily runs over anything that looks like a stream protocol. We've had people do it over TLS tunnels. We've had people do it over file systems. We've had people do it over Unix main sockets. It doesn't have to be TCP actually in there, but of course we're talking about the real world. So the one part is, alternate transports aren't themselves sexy. You can do BGP over a standard QUIC and not change much about the protocol, and it works perfectly fine with a small couple of tweaks. What sort of benefits are you getting out of those things? Well, there's a pile of things that are interesting about QUIC that can be helpful, but aren't necessarily the primary thing we're trying to solve. I'm going to come back to the QUIC things in a second, but primarily the thing that we're looking to do that isn't inside of the easy to reach stuff is BGP over streams, being able to send your address families over different streams that are unidirectional, which QUIC can give us as a transport property, which means when you have the terrible packet of doom come through that would normally knock over your session, and you're spending all your time resetting your session, and that link is out until it's reconverged, we can fail it one direction now without actually taking out the other direction, and for one address family.
How many have had well, maybe I shouldn't ask that question. We've heard rumors that people have had that packet of doom knock things out. Now, if you'd like to tell us that quietly, we'd love to hear. But
I hear about it plenty.
So we're trying to solve this problem that we've heard from various sources. I'll just be as the and we'd like to try to get you on that stream. The stream and the security is nice, but the most important thing is no packet of doom.
Yeah, basically layer 5 for BGP is where we're targeting our work. And as other people have observed, it doesn't have to go over QUIC. It can go over anything that gives us that property in the future. And to some extent, this is going to be an experiment because maybe QUIC doesn't work out so great for routing protocols. But by the end of our experiment, we'll have some proof of how does QUIC actually work or do not work for IETF control plane? And hitting some of the properties that are sort of interesting about QUIC that maybe is a value add on top of the stream stuff. QUIC has TLS in the background. It can use certificates. This is again one of those things that I say certificates and most people are like, oh, boo, this is a scary thing. Why would I ever want to use these things that expire in my network before I have sessions that could be up for several years in a row? Well, the answer is maybe that's the wrong tool in some circumstances, but maybe if you're doing other things with BGP, who here operates data centers that do EVPN? Okay. This is what I'd expect. So one of the challenges you have for any of your data center type traffic for BGP is provisioning things and preventing misconnectivity between devices. And there's an awful lot of vendor work going on for doing zero-touch provisioning of various protocols. We had an auto configuration series of work that we tried doing at IDR. It didn't get great traction, but it proved that the use case had interest to people. A thing that certificates could be useful for, again, not our main use case, is helping with the zero-touch things to prevent misconnectivity. Two devices don't talk to each other unless they're actually expecting these things to be there, and provision not from some third-party certificate authority, but from inside the house. So certificates could be useful. I think some of these are next slide. Actually, not next slide. So the other things that are in there that are of interest, quick and survive session resets. So if you have a link flap, TCP would normally just die. And if you're doing an ASBR that took 50 minutes to converge for some reason, it'd be nice if it could just simply hold its breath for 15 seconds, decide that it's been short enough time, bring things up, and it just keeps going. So in terms of resiliency, maybe we get some benefits there too.
And that may solve one of your problems, and so let us know. Or let Yingzhen know that about the problems. We're looking for feedback. We've got lots of tools coming. Anything else on QUIC?
Nope.
I think this is a really neat next.
It is definitely in science experiment category. We'll hopefully have some prototypes popping out towards the end of the year. And if you're interested in participating either in the standardization work here, or maybe trying some prototypes of the stuff that we're in the process of working through, let us know.
Let us know. Flowspec version 2, another okay. We've heard these issues. Flowspec V1 was done to get DDoS out. And what we've heard continually are that you'd like to have user-ordered filters, an action sequence, as well as the default, because you have certain things to do. And this may take you into your router acting like a firewall. Well, the first thing we did is we collected all the data and we created a Flowspec V2. And I went to the implementers and they said, too much to eat, right? It's a big stuff. What can you give me as a little stepwise progression? So that's what we're doing. We're trying to give the minimal subset, and that's what the IP basic is. What can we add as the minimal change to give you user ordering and maybe not even action ordering? So basic, Flowspec V2 for basic IP is something that we're doing to use our current Flowspec, current actions, and just add that little user ordering. There's a lot of interesting things. There's questions about what happens if you have 5 different filters you want to have installed all at the same time across your network. Well, Flowspec V1 did what I call the spray and pray model. You spray the NLRIs and you pray that it all works at the same time. We're trying to see if we can do anything better in the simplistic model. Or do we need to go to a more complex model to add more IP filters? Do you have filters you'd rather see? For IP, maybe deep payload, maybe you want to see TTL packets filtered on TTLs. We'd love to hear from your security people if they have input. This is a data distribution. This is not, BGP is, as you well know, is not a send something, get something back. It's a spray. Okay. And we're looking at trying to give more action functions. Can we give actions with a specific order so that actions happen? Because right now, different implementations may interact with their Flowspec V2 actions. They're on extended communities. So there are some other tools. Again, once we get through past the minimal subset, we're into the experiments. If you have something that you want to see in those experiments, let us know. Some of the DetNet or deterministic network people are trying to add this to their L2 things so that they can have their video conferences go at a specific time.
Yep, and throw an easy case in there. We had a good show of hands of people that are data center operators doing EVPN. One of the things you're probably familiar with is how do I throw into this mix the ability to do some firewall type actions without having to do it on all the edge devices, because that's the wrong place to do stuff for some of your tenants. So one of the things that potentially becomes enabled from Flowspec V2 as a feature is the ability to insert layer 3 filters into your data center traffic. Get itself in the middle of Geneva or VXLAN or something like that in terms of dig past this header for a specific set of tenants, apply the layer 3 filter, and do the things that Flowspec may be good for. We had presentation a little bit earlier today where we were seeing the very typical deployment model for a hairpin turn scrubbing device. Imagine being able to use Flowspec to dynamically intercept your EVPN traffic and actually send it off to a scrubbing device without having to build up a giant scrubbing infrastructure to handle that in the EVPN protocol itself.
If that's of interest, help us with the experiment. The next thing that I saw in your presentation was people were looking at SR routing and trying to do some filtering. Again, more filters for SR routing might come in the IPv6 packet or the SR MPLS packet. So again, those are things we're hearing, but we're trying to get the basic DDoS as the top priority. Give you more tools for DDoS help. Did I miss anything?
Nope, I think that's plain for
I
that.
think we got it all. Okay. Okay. You ever feel like there's a large bag in front of us? Well, one thing, the original creator of RC 4271, one of the co-authors, was Yakov Rector, and he said, guys, it's been a long time. It's been 25 years. Don't you think you ought to go to full standard? And he's pinged on enough of us, Tony Lee and myself and Jeff and K.R. Patel, our other IDR co-chair, that we're going to take a run in it. So what do you think? If you think, don't waste the effort, I don't want to see this, tell us that. We'll let it go. Up until this time, we've been so busy we hadn't even considered it. There's Long Live Graceful Restart has come out with updates to the L3 VPNs. Why don't you take the BFD since you're the BFD chair?
And this is also my draft. So this one was sort of interesting because I ran into somebody earlier this week just chatting about things. They didn't know I was working on this piece, and they were describing how a specific vendors, they turn on BFD support after the session's already up. It doesn't do the right thing until the session bounces. And this was another example where, BFD integration. BFD's been a very powerful, very helpful thing to a lot of our protocols. We don't have to run BGP with type timers and have BGP flake out. We don't have to run our IGPs. We don't have to use it for, rely on other probing mechanisms for fast reroute type things. It's been good plumbing. But we found there's a lot of sharp edges in how the protocol integration goes, especially in a multi-vendor environment. So there's been work called BFD strict across different pieces. We have some for OSPF and ISAS that have hit RFC already. We have another one that's working through BGP. The two goals for this is, number one, make sure that when you have two different implementations that want to use BFD, they do the same thing. There should be no surprises. And more importantly, there are circumstances where different implementations can deadlock against each other. Vendor A and vendor B do not interoperate. This will take care of that.
So, and that's shaken out some other things where we've realized as we go forward how we can make the whole process better. You'll find behind all of this, we keep trying to do a better job. Another thing we found is when we did the BGP tunnel encaps, the BGP way of carrying tunnels, we obsoleted IPsec. Why? Not because it wasn't valuable as a tunnel type, but because we couldn't find any solid presentation. So you're going to start seeing secure WANs coming in here in different flavors. You might see it out of some of the EVPN work. You might see it out of the SD-WAN. Okay, so that's another piece we've been working on. We had proposals for straight IPsec, but that didn't seem to catch any fire in the ITF. So if you're working with secure VPNs and suddenly you're missing a link that's secure and your vendor says, oh, that doesn't work and such, let us know. We'll add things like this. But it's a case of the old becomes new. And if no one says they want it to go on, we let it drop. And Jeff, I think that's the end. The question we have is, are we running a bullet train or are we two kids going on the track? And there's a locomotive coming. So let us know. With that.
Yeah, I think there's exactly one other comment to throw in here, which is, IDR is part of where work for BGP happens. IETF does other things like security domain routing. Those of you who do RPKI things are going to find, that is a place to pay attention to BGP-related things as well. And IDR does closely work with, CyberOps, where that work is standardized. And also we work with an operations group called GROW. RPKI is obviously an important thing for you, and one of the lightning talks we'll be seeing coming up talks about how that is being perceived by our friends at the government. So do we have questions?
Thank you for the wonderful presentations. Now to the audience, do we have any questions? Yeah. Please remember to introduce yourself.
Sure. Tony Tauber, Comcast. You had a bullet point on RFC 4271 to full standard. What's entailed in that, or what are the pitfalls, pro and con?
The fun part is, what happens anytime you open up and decide you're going to rewrite the Constitution of the United States? Right. There's places where that could sound scary, but the goal for full standard in IETF is we think that this is stable. We think we've addressed most of the edge cases. Now, we have errata open against several BGP RFCs. This is a chance for us to roll the stuff up into one place. It makes implementation itself a little bit easier. It also helps us find places that we know we have work left to do. An example of that is the finite state machine work, which the send hold timer work, the BGP BFT strict work, and the work that I'm doing with Yingzhen on the BGP QUIC is sort of highlighting that what we think is a clear state machine probably isn't quite right. Let's get a chance to clean up.
So it's not necessarily, our goal is to put it in a particular one spec so that you're not grabbing pieces here and maybe your vendor misses something. Downside, which is what I thought was inherent in your question, we spend time on it. And you get a new spec and the vendors spend time. Yeah, that's it.
Yeah, no, I get that part. When you say put it in one spec, like you would then pull all the different sort of...
We won't pull all of them. We'll pick what we think's focus on. Right. No, we're not having one spec fits all. We're pulling the ones that are immediately written on the actual 4271 spec. We're very focused on what should be there. You'll find in IETF standards, you'll say modifies 4271, and anything we have notes that we have, there is a BGP issues when we did 4271 that I'll go back and read the 200 pages to see if there's anything that should be clear in the text. We think it's solid. We're just trying to pick up any cruft that might have come out in the last 20, 25 years. Yeah.
Thanks.
Did we get it? Any other questions about that? Okay.
No more questions.
Thank you, by the way, for asking that. That I was hoping someone would say something.
Okay. Thank you again. We appreciate your contribution. Thank you.
Thank you. And again, if you're interested in participating in IETF and would like a little more information, please see us after.
Yep.
Thank you, Jen.
Sure.